So in this video we want to be looking at derivatives of inverse functions, and this is very essential, especially when we continue our learning of derivatives, because we're actually going to be looking a lot at derivatives of different inverse functions, such as the inverse trigonometric functions, the inverse of e to the x, and so on, right? So this is a very key lesson that will help us with future lessons about derivatives. So just a quick review on notation, right? Remember in our Algebra 2 class or in pre-calculus, we learned about inverse functions. Specifically, inverse functions hold this special property that if you place the function inside the inverse function, it returns exactly what this value is here. And we can actually write it the other way too. If we have our regular function and we input the inverse function, this is equal to what the inside thing here is, right? So a good example is that the natural log of x is the inverse of e to the x. So that means if we did e to the, and then we plugged in the inverse into x right here, the natural log of x, we actually get x. Similarly, if we were to plug in the natural log of e like this, it outputs x, right? So it kind of follows this. It does follow this, in fact. It follows this property. And many functions like these hold these properties. Even some polynomials we can rewrite in terms of inverse functions, and we can return something like this, x. So in this lesson, we're actually just going to be focusing on the derivatives of inverse functions, because those are especially essential in calculus classes when we actually find the derivatives of these two functions, and we'll see something very interesting about them soon. So let's go through what the formula of the derivative of inverse functions are. And a lot of people tend to forget this formula because they don't know what's actually on the denominator, and you'll see exactly what's on the denominator. But it's actually, in my opinion, much better to memorize or remember the process of getting to the formula instead of memorizing the formula itself, because even I forget the formula from time to time. But if I just know the process, I can always get to the formula and use it in whatever problem I'm given. So let's actually start here. So I'm going to use this fact, right? We're going to start with our basic principle or basic property that just outputs x, and that's not a terribly difficult statement to begin with, right? You just have to remember this. This is a property of inverse functions. Now we want to take the derivative of both sides, right? And it's kind of interesting that this is even a thing that we can do now that we learned the chain rule, because this is a composition function, right? Something inside of another function, and we know how to take derivatives of those pretty easily, right? Remember, you want to take the derivative of the outside and keep the inside the same, so I'm going to write it like this. And then you want to multiply by the derivative of the inside function, which I'm just going to write it like this, just for simplicity's sake. You can write it the other way, but this will just be much nicer to look at when we finish. And then now we just simply we know what this term is, right? This is what we want to find, but we want to basically solve for this now. So we just divide the other stuff, and this is the formula that we end up with, right? And again, I'll reiterate it here. A lot of people just forget, is it f prime first, or is it f to the -1, or is it the inverse here and then f prime, or which order, 1 over something, right? It's really difficult to memorize this formula, but it's easier to memorize the process to get to the formula, because all you have to do is remember this property, and should be something that will be ingrained in your head, especially in future calculus topics. So, and then just a quick review. We take the derivative of both sides using this property, and we just apply the chain rule, right? We should know the chain rule pretty well now, that it shouldn't be more difficult than the actual derivation itself. So we do that, and then we just solve for what we want, which is the derivative of the inverse function. So here it is. I'm going to highlight it just to show you. In fact, let me just scribble here. In fact, I'm going to highlight the whole thing, because the whole thing is actually more important than the end result. This is super important. Just to know this process, and it also just helps you get into the mindset of how to problem solve in calculus and the general framework we want to use with solving stuff. We usually like to start with a basic principle, and then we find the derivative, and then we solve for what we want. So we're actually going to be doing one example, so I'm going to write one here. We have the example, given f of x equals x squared, find the derivative of the inverse function at x equals 4. Right, that's what this n means in words. So I just pretend I don't know the formula for the inverse, right? So we're going to actually start from basic principles. So we're going to start from our basic principles. And if, I guess you might mix up, do you want to the -1 here or do you want an f? I just remember that we want to apply the chain rule, so if we end up getting the derivative of this outside of this, right, then we're correct. So you can already find if you messed up on the first step, which is always helpful than trying a formula that actually doesn't work out. So I'm going to go from the beginning. So d dx of this, and we get 1. I'm just going to already evaluate that derivative, and it's, now we go this, right, the derivative of, keep the derivative of the outside and then keep the inside the same, and then multiply by that chain. The notation that you would use for this in the not Leibniz notation, more like the Newton style notation, is like this. Is this equal to 1, and then we found that the derivative is equal to 1 over, oops, like that. Nope, not like that either, like that. Oops, let me just make this a little bit more clear. Oh, let me just rewrite this actually. 1 divided by f prime of f minus 1 x. Right, this process is actually, I feel like it's much easier than taking the effort to memorize this formula. So now we can actually begin the problem. And it also takes like a good, just 30 seconds. It's not too bad. So now we want to begin this process of answering the question. So given f of x is x squared, find the inverse function derivative at 4. So basically here we want to just plug in 4 straight here. 4 is equal to, and then anytime we see an x we plug in 4. So the hard part here is actually, what is this value? What is f to the negative, or the inverse function evaluated at x equals 4? So in fact we actually have to find the inverse function. So that's something we learned in Algebra 2. If you don't remember, I'll just give you the quick reminder. So think of it like this. We want to write it like this. So here, let me write it in a different color so you know that we are doing something on the side. So think of it like this. Y equals x squared. What you want to do is switch the variables so that x is now y, right? I just swapped them. Like this, right? So now x is equal to y squared, and then you just want to solve for y once again. So y squared, let's see, so to solve for y we want to take the square root of both sides. Right, that's the inverse function, and it's positive because that's also another thing we have to keep track of, because inverse functions are not, if we kept the plus and minus, then it's not really a function anymore because it fails the vertical line test. So that's why I'm just going to use this value. Now we found the inverse function. What does that tell us? Right? I'm just going to rewrite it as the inverse function. Oops. There we go. So now we can just actually plug in f to the negative, or inverse function, and go like this, right? Which is equal to 2. And interestingly enough, we can check that it actually works is by plugging it into the real value, and we should get exactly what this is, right? If you want to think of it like a picture, here's f of x, and here's the inverse. So when we plug in 2, we map it to the output to get 4. This is following the f of x function, and then to get from here to here, we want to plug it into the inverse function. So it kind of remaps it back if you want to think of it in terms of a picture. So that's why we end up getting a 4 to 2, and then we plug in it back to the function, we should get return 4. So now we know that this is more of the key part of the question, right? So now we want to return to our question, we want to return, let's see if there we go. So we found that off from our side work, the inverse function evaluated at 4 is 2. So now we actually just want to plug that in here. So continuing our work, it's 1 divided by f prime of 2. And since our function, here let me do it in a different color, so this is different side work. Since our function is this, we just simply want what's f prime of 2. Well, in fact, if we just find the formula for the derivative using the power rule, and then we just plug in 2, we get 2 times 2, which is equal to 4. So then in all, let's see. In all, what do we get? We get 1 over 4. And that's the derivative of the inverse function of x squared at the point x equals 4. So just a quick recap. So we are given this function, we want to find the derivative of its inverse at 4. What I did is I pretended I had no idea what the formula was, so I derived it myself. If you end up memorizing yourself, you just skip like a good 20 seconds because this doesn't take that long. So I don't think it's not really that beneficial to memorize it, even in my opinion. So we get this formula right here, and we want to evaluate at 4, so I just plug in 4, so we get this. And then this is where the work really comes in with inverse functions. So I did it in blue right here, up here. The process for finding an inverse function is basically swap the variables and solve for y once again, and then replace y with the inverse function. So that's what I did here. So we got square root of x, and then now it's a function kind of in its own way. So I just plugged in 4, and then I got 2, right? That's what it outputted. And then to know that it's a true inverse function, we plug in 2, and we should get back to our original thing, right? This picture will help us. This maps of f of x from an input to an output. The inverse function maps an output to an input, if you want to think of it like that. So we found that the inverse function evaluated at 4 is 2. So right here, where my mouse is, 1 divided by f prime of, we know what this value is, which is 2. So now it's, in fact, 1 divided by the derivative at x equals 2, and we know how to do that. We've done a lot of derivatives, especially with this kind of function, right? It's just a simple quadratic. So we find the derivative, and then it's 2x, and we just plug in 2 to get 4. So now we just simplify through and substitute, and we get 1/4. Let's do one more example. This problem, or this example here, is actually not just a typical function. It's just going to be a table full of values at x, g of x, h of x, and g prime of x. And we're just going to see how well do we actually know this idea of the inverse function and its formula. So here's the question. Let g and h be inverse functions. What is h prime of 1? So remember that g is the inverse of h, and h is the inverse of g. But in this case, g is kind of like our main function, and h is the inverse that we're talking about, or that g to the minus 1, if you want to think of it like that. That's kind of like our h in this case. So then what is the formula, right? We need to derive it, because in this context it might be a little bit more confusing, right? So if g and h are inverse functions, they satisfy this property, and I'm just going to quickly go through this, right? And h is that inverse function. Just remember to keep that in mind. Oops, this is not x anymore, this is 1. Right? Now we want to find what h prime of 1 is, what the question's asking, right? And that's precisely g prime of h evaluated at 1. So now we can actually look at our table. What is h of 1? Well, if we look at this table, we have when x is 1, h is 3. So then that means it's equal to 1 over g prime of 3. And then now we want to look at what is g prime of 3 according to this table. When x is 3, g prime is negative 2. So this is actually equal to negative 1/2. And this is kind of like a AP style question, and they would give it to you as a multiple choice most likely, because you can do these pretty quickly, or you should be able to do these pretty quickly. This process took me like 10-20 seconds at most, and then the solution would in reality just take a couple seconds also, because it's just plugging in values from a table. But the main idea is mostly the inverse function is this concept that is given by this and given by this derivation, and then we just plug in what we know to find our answer. So that's it for inverse functions. So I don't think there will be another part because this is just a small topic. So that's it.